Okay, everyone, welcome to our Junior Topic 7 session. We're going to be looking at representing fractions today. Thank you, everyone, for joining us. We are going to start with our territorial acknowledgement. We'll be looking at the ethical standard of trust. The artist of this painting, Elizabeth Dockstader, from Six Nations of the Grand River, describes her painting. We chose to focus in this slide, sorry. She says, the ethical standard of trust embodies fairness, openness, and honesty. Members' professional relationship with students, colleagues, parents, guardians, and the public are based on trust. The moon is the grandmother to us all. Grandmother Moon is responsible for the ocean tides. She decides when to plant gardens and when to harvest crops. We chose to focus on the ethical standard of trust today because whenever we come together for shared professional learning, it's important for us to keep fairness, openness, and honesty in mind, both in decisions we make for and about our students, and in working with one another. With this in mind, we would like to begin by acknowledging that the land on which we gather today is the land traditionally used by the Haudenosaunee, Anishinaabe, and Neutral people. We also acknowledge the enduring presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share this land today. So we're going to jump into looking at our agenda today. There's a few things we're going to cover. First thing we're going to talk about is we're going to talk about pacing. How do we fit all these topics in to the time that we have with all the transitions that we've been experiencing? Then we're going to get into topic 7. We're going to explore the LRP site and the 2020 digital math curriculum site. Then we're going to talk about representing fractions, exploring equivalence, talk about comparing and ordering fractions, and then we're going to have a little bit of time for questions and answers. And interspersed through this, there'll be opportunity for us to interact with you. Let's get started with this question. Take a moment just to let us know what topic you're currently teaching in math. This is just to provide us with a little bit of data for us going forward so that we can be responsive to you. So I'll give you about maybe 20 seconds or so. If you could select a response. And
it looks like lots of people are not yet in the Pear Deck. So please go to the chat where Minu has posted the link and join the Pear Deck so that you can participate.
Yes, thank you, Michelle. This is one of a couple slides that are interactive that you will need to be on the Pear Deck to engage with. Okay, so we're going to keep marching on here for the sake of time. Let's talk about pacing here. We recognize that there's a lot for us to go through these topics on pace, and we have provided a document to give you some strategies for efficiencies in instruction. So we're just going to pop out of the Pear Deck here and take a quick look at this document together. It is linked. Click on that, and I'm going to share this tab with you. So how can we fit it all in? There's a lot of challenges.
Lost you. You're no longer presenting your screen.
Oh, sorry. Glitch. Let's try that again. Thank you, Michelle.
Mm-hmm.
All right.
Better.
Excellent. So this document just outlines some strategies for us to try. And I will give you time, I recommend that you take time, to look at it afterwards. I'm just going to go through it a little bit, give you an overview. Some of the strategies to help us create efficiencies in our instruction, because, even before 2020, it was always difficult to fit everything in and to try and get our students across our continuums of learning. So number one, we want to consider how some topics are revisited across the school year. The expectations describe learning goals, targets for the end of the grade. That's something that we want to keep in mind. It's not necessarily at the end of that topic that you will have that expectation. or your students will have that expectation covered or conceptually understood. It's at the end of the grade. So a number of things are revisited across topics, and there's lots of examples. There's an example here in addition, but what you want to keep in mind is we're not waiting for all of our students to get to competency to say, now we're ready to go to the next topic. You know, there is room for revisiting things, revisiting concepts, and they are interwoven across different topics. So it's important to keep that in mind when we're planning and when we're deciding, you know, the progression through the topics. Number two, we want to use recursive strategies to chunk some topics into smaller blocks, you know. Consider what are the most important concepts and skills to address. You know, and we're going to do that while we're planning a week of instruction to introduce some of these concepts and skills and following up with some smaller things to revisit. So you might plan a week of introduction into a concept, but go back and you know, revisit that with a math talk, or integrate it into another subject, or a quick morning message routine, or a purposeful practice. So it's not, sometimes we focus in on a topic and make it to be drawn out more than it needs to be. As opposed to having that week planned of introducing those key concepts, skills, and giving opportunity for experiences later on. Number three, we look at strand. The number strand is one of the concepts and skills that support learning in all of the other strands. So interpreting and analyzing data representations encourages students to apply number concept skills. So we want to, you know, keep overall expectations in mind when we're planning. So think about the overall expectations as opposed to jumping into specific expectations too soon. And that gives us a kind of a broader range to be able to plan. Let me see if yeah, I think that's, so with all of this said, oh yeah, assessment data. It's important to use assessment data to make sure that what we're teaching is actually what the students need, right? Sometimes we might take a bunch of time covering a concept the students are already there at, and maybe you only need a small group breakout or a small group instruction to get the few kids that need that, as opposed to spending the whole class teaching something that students are already adept at, already show competency and are ready to move on. So getting assessment data and being responsive in our instructional strategies and decisions for assessment data is important. That's one way of saving time. And of course, as you're going through this, your learning support services consultants are available to help you support your planning, to help you be more efficient, to save time. So I'm going to pop back into.
You may have a yeah, you kicked you out again. Apparently, some people are saying in the chat that the switch tabs is not working. Like share this tab instead has not been working.
Oh, we've had glitches.
I'm not aware of it. Yeah.
Oh, okay. Yes. All right. So I will stop and I'll start again. Thank you guys for the information. That is new. Okay. Let me know. It looks like, am I live?
Yes, you're good.
Excellent. Thank you, Michelle. Okay, so we've been discussing some of those things. We're gonna jump into topic 7, representing fractions is what we're here for. Just keep in mind this just-in-time session, along with the previous topic sessions, are all available on the LRP site. So these resources are all there for you to check out. We're gonna take a moment now. I'm gonna jump out again, so this is gonna be probably not the best, but that's okay. We're gonna take a moment. We're gonna go through some of the curriculum expectations across topic 7. I'm going to jump into the LRP site, and I'm also going to jump into the digital curriculum site for us to. So it's going to stop sharing, and then I'm going to, sorry. All right, so here we are in grade 5 for topic 7 at the LRP site. And in grade 5, we're looking at grade 5 because we're going to look at the grades across 4, 5, 6. But this topic focuses on B1 from number strand. And then under expectation B1, we're focusing on students representing fractions in drawings, models, tools, and fractional notation. We're focusing on students comparing and ordering fractions across the grades, and we're focusing on students showing equivalency between fractions, decimals, and percents through 4, 5, 6. So let's jump into the digital curriculum site. I'm going to stop presenting.
And if you do share your whole window, Hebron, that would probably
yeah, I could do that. Because we don't have any sound necessarily here. It's perfect. Thank you for that solution. All right. I think I'm live. Am I good?
Yes, you are. Yep, you're good.
Excellent. So let's jump into the compare grades here, looking at 4, 5, 6, and we're going to scroll down to fractions, decimals, and percents. Okay. We'll notice that we're representing fractions in grade 4 from halves to tenths. Again, grade 4 is using drawing tools and standard fractional notation, which is something new in grade 4 for representing fractions. And you can see across grade 4, 5, and 6 that representing, just grade 4 and 5, sorry, representing fractions grows. In 5, they're using equivalent fractions. They're dealing with improper and mixed numbers. And again, using fractional notation for representing. As we go down to, working with comparing, grade 5s work with fractions from halves to 12s, comparing and ordering, and they have, again, improper fractions and mixed numbers. Grade 4s don't work with improper fractions and mixed numbers. In fact, grade 4s, when you're looking at, comparing, they're looking at individual portions that result from fair share scenarios. And this whole fair share idea is actually something that's in primary, and it continues into grade 4. And you'll notice in grade 4, when they're comparing fractions, they're still using models and drawings to represent and compare. They're not focused on as much notation under that in grade 4. So they're kind of transitioning, being exposed to notation. The notation, again, is really focused on what the denominator means and what the numerator means. And we'll talk about that later on in the presentation as well. One of the things I wanted to point out here is you'll notice that in this section, grade 6 doesn't really have much to do with fractions, except for dealing with equivalency of fractions from decimal numbers to decimals and fractions to the thousands. So that's the only time fractions actually shows up in the representing fractions part for grade 6. But we know that our grade 6 students are going to need, as always, to be able to look past grade 5 and grade 4 content to see what they need and where they need to go. So in grade 4 and 5, we are actually comparing fractions and decimals. 4 is dealing with tenths, which is down here 1.9, and 5 is dealing with hundreds. All right, so that's kind of a quick 4, 5, 6 overview, how that gradually, we'll take another look at this as a bit more visual later on. I'm just going to go and show you some of the teacher supports that are available here. Teacher supports are always a great place to find, further break down the specific expectations, to find meanings of what they mean and examples and key ideas that I want to understand before I jump into that topic. I'm going to jump into 1.3 here because this is something that shows up across 4, 5, and 6. And it's the idea of what a fraction can represent. So a fraction can represent a quotient. That's division. It can represent a part of a whole, which is something that we're very used to. It can represent a comparison, and that's something that's part to part, that we've usually call it part to part in this curriculum. In the new digital 2020 curriculum, they call it comparison. And then it can represent an operator. So again, the teacher sources, the teacher supports are a great place to find some of this. If you see a word that's underlined and if you're not sure what it is, it just indicates that there is a glossary there that you can click and open up to get a definition. Sometimes there's visuals to go with that. Sometimes there aren't. So it's a great place to visit. I'm going to pop back into our LRP site now and take a look. So we've taken a look at the expectation cluster. As always, there's math up lesson correlations here that we have available for you to look at math up, and we're updating those on often. Along with that, we have additional problems that you can use. Here, the additional problems are broken down by different models. This is something Michelle's going to touch on later on, but these prompts are there for you. Along with that, there is also actually a sample problem document here. So that when you click on more, what it does, it takes you to a printable form of the expectation cluster, along with a number of sample problems that you can use as prompts for your planning math. Further down, if you keep scrolling, I want to highlight this Building Fluency Math Talks section. We have number talks from Math Up available there. There we've got fraction talks for this topic. This Building Fluency section is something that's always available for each topic, and we have fluency pieces that fit with that topic. And then we've also got a parish number talks that are centered around fractions that you can reference. The bottom of the page here, I'm going to quickly go over this because this is becoming more and more important, especially as people are distance teaching, is the virtual learning resources. So we've got various manipulatives, various resources that are virtual, that are available there for each topic. So that's important to look at there. Okay, so let's go back to our slide. So when we talked about this earlier, we were talking about the continuum. We just wanted to create something that was visual, that's kind of readily available for you to look at, to be able to grasp the continuum concepts that show up. Some of that primary fair sharing concepts that were there that we talked about, I said, comes into grade 4 is here. Primary is all about fair sharing. There's representing in drawings and a very big focus on fair sharing. Primary is exposed to whole, mixed, and fractional amounts. And they do actually work with some equivalence in fair share scenarios represented in models and drawings. We see that grow into the grade 4 here when they're dealing with fair sharing or when they're comparing. And some of the that was mentioned, the denominator and the numerators here. So this is kind of a visual way of looking at what we saw in the curriculum 456 expectations. We've outlined kind of, okay, in primary, we're representing in drawings. In junior, we're representing in drawings, models, and tools, and fractional notation becomes really big in grade 4. And we've kind of outlined, in grade 4, they're dealing with representing up to tenths. In grade 5, they're going up to 12ths, dealing with improper and mixed. And then there's comparing, and then there's equivalencies on the bottom, as we've talked about. So that's a good reference point to visually see the continuum, a bit less text heavy, hopefully. All right, I'm going to pass it over to Michelle, and she's going to take us into some key concepts in fractions.
Thanks, Hebron. I just want to start by acknowledging that there is no other area of elementary school mathematics that is as mathematically rich, cognitively complicated, and difficult to teach as fractions. That's because fractions express relationships, and it's the first time in junior that students will encounter the symbolic numeral 3/4, for example, 3/4, that represents a relationship between two discrete quantities. And because it's so cognitively complex, we really need to make sure we understand as teachers what some of these key concepts are and expose our students to all of these ways of thinking about fractions. So first of all, there's different types of fractions. We are all familiar with the proper fraction. A unit fraction has 1 in its numerator. A mixed fraction, also called a mixed number. Improper fraction has a numerator that's greater than the denominator. And then the word complex is grayed out. Complex fractions are fractions that have a fractional numerator or denominator. So a fraction as its numerator or a fraction as its denominator, or both. And complex fractions aren't addressed in elementary curriculum. But as a teacher, it's important that you're aware that they exist. So sometimes we see a student who might put 1/2 as a numerator, and we say, no, you can't do that. Well, in fact, they can. And so we have to be really careful about misconceptions and guiding students on the wrong path. Unit fractions, when we're thinking about unit fractions, that's a really key understanding. Students understanding and being able to count by unit fractions and recognizing that any other fraction, for example, 5/6, is simply 5/1/6 combined. So that's an important key concept for students. Hebron touched on this, and we're going to look in more detail about that whole idea of the whole and meanings of fractions. Equivalency, we'll spend a little bit of time looking at the merging and splitting and the emphasis on visual. And then we'll look at different ways of comparing and ordering, because all of these key concepts we need our students to have experience with. Okay, next slide, Hebron. So looking at meanings of fractions, the one that we are most familiar with is the part-whole representation. On this slide and the next few slides is a link to a document called Paying Attention to Fractions from kindergarten to grade 12. So that's where all of these visuals have come from. This one, as I say, is the most familiar, the part-to-whole relationship. One of the mistakes we make, again, especially in primary and early junior, is having the students use the phrase out of, so 2 out of 3. That's fine in some contexts, but then it doesn't make sense when we get into improper fractions in grade 5, because 3 out of 2 doesn't make sense. So instead, we just want to talk about partitions. So the part is the part we're concerned with, and the whole is broken into equal partitions. And that's how we want to think about when we're thinking about part whole. Okay, next one. A second way is to think about that part-part comparison. This is where we often think about ratios, and we don't make that connection for students that this is also a type of fraction, a part-to-part comparison. So for example, in the picture of the fruit, the fraction, the number of fruit in the set that are pairs is 3/6 the number of fruit that are not pairs, or that are other fruits. Similarly, with the visual of the water, 4:3 describes the part-to-part relationship of this container of what's filled to not filled. And helping students with that recognition that that is a fraction, but it's not a out of relationship. Okay, Hebron. Fraction as quotient. So as Hebron mentioned, in the primary grades, there's a huge emphasis in the curriculum on fair sharing, because that's sense-making for students. Primary kids often are fair sharing, whether it's cookies or toys. That is brought into the junior, and we can use this idea of fair sharing when we think about fractions as quotients, especially with these improper fractions. So something like 6/4, I have 6 things, and I'm going to divide it among 4 people for fair sharing. Or on the number line, there are 6 parts, and I'm going to repartition them into 4 equal parts. Each of those equal parts is going to be 1.5. So that's fraction as quotient, dividing it into fair shares. And the last meaning of fractions is fraction as operator. We're not going to get into that today because we're focused on representing, but it's important to note that across all the junior grades, students are responsible for being able to multiply a whole number by a fraction. And it gets a little bit more complex through the junior grades. So that's another meaning or understanding of fractions. For example, 1/3 of a set of marbles, or a boy walked 1.5 times as far. That's fraction as operator. Okay, next slide. In addition to those meanings of fractions, we want to make sure students are exposed to and have experience with these different contexts. So Hebron and I have both mentioned, and you've seen examples so far of an area model, a set model, and a linear or number line model. We want students to have experience in all of those. Traditionally, we had a huge emphasis on area models. And so in junior, if you can aim to have your students exposed to more set and linear models, it should balance it out. We also want to give students tasks or problems that have them think about different aspects of that part-whole relationship. So if I give you the whole and ask you to represent a given fraction, that's one type. Or I may give you the fraction, ask you to represent a whole. I might give you the whole and a part and ask you to tell me the fraction. So we're going to give you an opportunity to experience some of what that looks like in a few slides. The other thing we want to make sure is that in grade 5 and 6, students are regularly using proper and improper. So we don't want to focus on fractions and just do proper and then say, oh, and now we're going to look at improper, because then students see it as something separate. Proper and improper are just two different representations. Like it's a continuum. So we want students, when I talked about unit fractions, if they're counting by unit fractions, we want them to go beyond one whole. So if I'm counting 1/3, 2/3, 3/3, 4/3, 5/3, so they recognize all of those are fractions. And if it's beyond a whole, it's now an improper fraction. Using both words and symbols. So by junior, we often forget about the words, and we want to make sure students are seeing the words and symbols in those junior grades. Okay, Hebron? So this is a reference slide. There are lots of tools and models that we can use to represent fractions. These are the most common. So the 4 visuals on the left are the kinds of concrete materials we often have in our classroom. The Cuisenaire rods, 2-color counters, pattern blocks, fraction tiles. You may have fraction circles. In the current environment in which we find ourselves, we also need to have virtual versions of these. So again, we're going to give you an opportunity to explore in a couple of minutes some of those virtual versions. On the right, we can see double number lines can be really helpful, and we'll look a little bit further at those, and ratio tables. So again, this is a reference slide that will stay in the slide deck, and we'll invite you to revisit that later. We're going to move on to the next slide to give you an opportunity to try some of these things. So there are 3 different links on the page. Actually, there's several links, but there are 3 different virtual tools that are linked, and there's 3 different prompts for each tool. What we're going to ask you to do is do a little bit of exploring, and once you've explored something and answered one of the questions, we're going to ask you to take a screenshot and share your thinking in the Jamboard. So this is going to require that you have 3 tabs open. You're going to have a tab where you're working on the resource, a tab where you can see the question, and then the 3rd tab would be the Jamboard that we want you to take a screenshot. We're going to take about 10 minutes. It's going to be kind of quiet because you're going to be off working in your own little world. I might pipe in every now and again just to ask you to share any screenshots that you might have in the Jamboard. If you have questions, feel free to pop them in the chat. We're a small enough group that if you have a question, feel free to unmute and ask aloud as well. So we're going to set you off to do that. Click on one of those and explore those questions. Just a note too, there are actually 9 different slides in the Jamboard, 9 different pages, one for each question related to each of the virtual tools. So thank you to those who are already uploading screenshots. Just a reminder that there's a new page for each question in the Jamboard. So we're going to take about 2 more minutes. I'm going to invite you to, if you haven't yet tried the third bullet in one of the 3 sets, to do so, because the third one is the most challenging for each of the tools.
So Michelle, there's a question in the chat.
Yeah.
Mouse pad is not cooperating. Is there any way she can use without the mouse pad?
To maneuver the shape. So Tammy, which resource are you trying to use? The Jamboard or one of the tools?
I was trying to use one of the tools, but my mouse pad won't let the things turn around. Like I can drag them on, but that's about it.
Oh, and then, well, so I'm not sure. I would have to go into this specific tools to check, but you might try arrow keys once you've got it selected.
Okay, it wasn't working for me. I'll try a different thing.
Yeah, that's too bad. I'm sorry that's not working for you. Which one was it, Tammy?
I was trying to do the yellow hexagon.
Okay, so the pattern blocks.
Yes.
Hmm. Okay, I'm going to invite you to head back to the meet. Hebron, I'm going to ask you to stay in the Jamboard for a minute. And if everybody can come back to the meet tab, you will be able to see the Jamboard. To be able to copy to the Jamboard, the best way is to do a screenshot. If you do a screenshot and then upload or drag, insert into the Jamboard. So it depends what device you're on, but a screenshot is what you want to do. Tammy, Ryan was providing a suggestion for you in the chat that if you hover over the shape, there'll be a gray manipulator, and if you click the gray thing, it will manipulate the shape. I'm not in the tool right now, so I don't understand that, but it's something you might try. Okay, Hebron. I'm going to ask you to go to slide 5, please. So on slide 5, I want to talk a little bit about what you might do with students. So if you've assigned this task to your students, one of the things, like in this particular slide, it says show what the whole would look like if the red trapezoid is 3 halves. So here I would want to ask a student, how do you know? Because it's not really clear. I can infer, but this is where I can get some really good explanation from a student, where I can have a student explain their thinking. Or even if it wasn't their thinking, I could ask for a volunteer to explain. So how do we know that the blue rhombus is the whole? And it gives a student a chance to explain their mathematical thinking. You get at their fractional understanding. So let's compare that slide to slide 9, Hebron, please. So on slide 9, the communication is really clear. And this would actually be a good example to talk to students about in terms of what makes communication effective in math. Because I can see when the person first, I was kind of creeping this slide. And as a teacher, it was a bit frustrating because somebody posted something similar to the image on the left, but only 2 were yellow. And then it disappeared. And I was like, oh, I don't understand. What are you doing? What's your thinking? So that's the frustrating part of using a tool like this. But now I can see that, I believe, whomever it was, adjusted their visual, and now it's really clear. So if 10 counters are 5 halves of a set, how many counters are in one set? Now I can see I can see 5 rows for the 5 halves, but then they've outlined to show me, oh, how much one set is. And similarly, the one just to the right, I can see that they've divided it up to show the 2 wholes and then another half, and they've shown that it's 2.5. So that's just a couple of points that I wanted to make about what you might see with student work and how you might prompt or probe your students to explain their thinking and have a conversation about what makes their thinking clear when you're doing visuals like this. Okay, Hebron, we can go back to the presentation, please. So our purpose there was just to give you an opportunity to explore, to see what those tools do, and to model those types of questions where you might be given the whole and asked to find the fraction, or given the whole and a fraction and asked to find the part, and making sure students are exposed to all of those. So this now serves as an example or a model that you might use. And I believe I'm turning it back to Hebron.
Yes, so we've done some really good experiencing. Now we're going to jump into equivalence, the idea of equivalence. So when we're dealing with equivalence or any exploration in fractional ideas, it's very important that we have an emphasis on visuals. They're key for students to understand. As you saw, you were working with different models that are visuals. Again, this was mentioned before, exposure to set models along with area models and linear models is important. Various models is important for students, right? We tend to stick to the area model because we're comfortable with it most. So here we see a set model where 4/6 of the whole set is green. And by merging two parts, you can see in the second row there, by merging two parts, we can see that 4/6 becomes 2/3 because we merged that first set of green, second set of green, and the third set of green, the white, right? So those couples merging two at a time. You know, the opposite is also true. We can use splitting to find equivalence, right? We see that when we split each set, each part of that set, each piece, then we have, instead of having 4 that are green, we have 8. And then the total, instead of being 6, becomes 12. So we have 8 12s. So that's one model, set model of exploring equivalence. Here we're going to look at number lines, a linear model to explore equivalence. We're dealing with merging partitions and splitting partitions. It's really good that students are exposed to this visually, merging and splitting to deal with equivalence. We're not jumping into notational stuff, if you notice, right? So here we have 12/8 is the decimal we're working with to start on the top number line there. A double number line, by the way, is a number line that can be used to show equivalence between fractions and other things based on the top and the bottom and the partitions, right? So we've got 12/8. There are 12 partitions, and 8 partitions we can see makes a whole. So here we're going to merge 4 partitions, so that we have at a time, so that we have one partition there that's larger, made of 4, and then we have a second one that's a larger one made of 4, and a third one that's made of 4. So 2 of those larger merged partitions make a whole in this case. And then we have a total of 3 of the larger merged partitions. So if you're thinking about that in terms of 8s, the first larger partition is 4/8. The second one in the middle gets us to 8/8, and the third one gets us to 12/8. And when we look at the larger partition, we can see that we've got 3 large partitions, and 2 large partitions make a whole. So that gives us, a half, 2 halves, 3 halves. It's important to note here that we can only merge partitions when we're merging such that there's no leftovers. So it wasn't just by random that we picked 4 to merge in this case. And then we're going to look at the second number line there, still dealing with 12/8. Now we're going to split those partitions. So 12/8 has been split into 3 parts. So each partition has been chopped further into 3 parts, and that gives us 36 partitions, and 24 partitions make a whole in this case. So we're using merging and splitting in both cases, in the set model and in this number line model. We can also use double number lines to deal with equivalence between fractions and decimals. Here you see this double number line that's dealing with chunks of tenths, and it shows the decimal equivalence on the top and the fraction on the bottom. Now we're going to jump into strategies for comparing and ordering. We have a prompt for you. We're going to do a 3-2-1 waterfall. Okay. If you haven't done a 3-2-1 waterfall before, it's a really good tool of engaging students via the Google chat. This is how a 3-2-1 waterfall works. I'm going to give you the prompt. This is a prompt, so which is bigger, 3/4 or 5/6. You're going to just type your response. You're not going to press enter yet. So I'm going to give you some think time. You're going to type your response. You might have some thinking to type as well along with that response. That's fine, but do not press enter. You're going to hang on to that typed in your chat. And then I'm going to, after giving you some think time, when I feel like we're ready, I'm going to say 3, 2, 1, waterfall. And when I say waterfall, you're all going to press enter. And we're going to see a nice digital waterfall of text in our chat. All right, so I'm going to go ahead and leave that prompt up for you. I'm going to give you just a few seconds of think time for you to type and think, and I will prompt you for our waterfall in about 10 seconds or so, maybe 15. All right, I'm assuming by now you've got some type of response here, and we're ready to, it's all typed in. We're ready to press enter. 3, 2, 1, waterfall. All right, it's kind of fun, right? I'm just going to speak to that 3-2-1 waterfall strategy. There is actually an intentional purpose for it, and what it does is especially in intermediate, junior grades, there's an apprehension to share your ideas, even in the chat, and it kind of alleviates that pressure because everyone's able to share their thoughts at the same time without having to have someone's thoughts or ideas kind of focused on it at once. So this kind of alleviates that pressure for students, so they can just share and everybody's ideas are there at the same time.
Just to add one more thing too, is it the idea that it gives students think time, because if you ask the question, kids just pop it in the chat, you're going to get the keener who pops the answer in the chat, and now the rest of the kids stop thinking. So it allows for that think time, and then all of your students had a chance to process. And you know what, even if there's a couple of students who didn't pop it in the chat because they're reticent, they've had that think time, they've done the thinking about the math without somebody interrupting their thinking with an answer.
Awesome. Yes. Thank you. So let's talk about this actual prompt, which is bigger, 3/4 or 5/6, right? Here we're looking at some comparison strategies. We're going to break them down to you. But once a benchmark has been identified, in this case a whole, we look at how far away from a whole each fraction is. And when you look at that visual, since both happen to be 1 away from reaching the whole, we have to figure out how far away the unit fraction is of each. So we've got 1 piece away from a whole in terms of the sixths, and we've got 1 piece away from the whole in terms of the fourths. And so we then get into understanding the value of the denominator, as well as what how long that piece is. And in this case, a quarter is longer than a sixth. So actually 3/4 is further away from the whole, behind the whole, than 5/6. So 5/6 would be greater. There's a lot of logical steps we're taking here. And it's important that things are represented visually so that students are able to think about it and understand and visualize it. Okay, so we are going to give you some time to get into some breakout groups. We're going to look at this prompt. Which fraction in each pair is greater? And when you're doing that, we want to think about which benchmark and how far, right? We talked about 0, half, or whole as a benchmark and how far it is from the benchmark. So I'm going to get us into breakout groups here. Groups of sorry, you're going to have to be cognizant of 5 rooms, 6 rooms, 7 rooms. All right. And then I'm just going to, I know you're watching me organize this. It gives you a bit of a background of, oh, room and where's the name? Perfect. All right. All right, we'll see you guys. So just give you 3 minutes to chat about that prompt. Off we go.
Hi, Shannon.
Hey,
Are you just joining in?
no, I've been here. I went to my breakout group, but it's just me.
Oh, is that right? Were you at number 2?
I was in number 3.
Number 3. Oh, maybe people left.
I had nobody in my breakout room.
Oh, yeah, me neither.
Okay. Well, I don't have the control, so I cannot put you two together. So maybe we can discuss it right here.
Sure. Can you pop the link to the Pear Deck in the chat again? I seem to have closed it. Thank you. I'm going to try my group one more time and see if they're there.
Sure.
And then I'll come back because they likely won't be.
Yeah, that's fine.
I'll be honest, I'm really nervous about this fraction unit in particular because I think I teach a 4-5 split, and I think this is going to be so hard for the kids. I'm really concerned because it's not just in the best of times, especially the improper fractions are so tricky, but the fact that they don't have the base from previous years is I'm just not sure if we just jump right into these things that I really think some are just going to really struggle with, or do we go back a little bit for what they might be able to do? Especially because like last spring, for example, a lot of kids didn't get fractions.
That's right. And that's why, Debbie, we said, so diagnostic always helps. And then starting from where they are and slowly moving along. And I don't know if you're aware that we have drop-in sessions that you can drop in and we can maybe discuss individually what the scenarios are and maybe help you in those sessions.
Yeah.
Are you aware we are having a drop-in session almost every day for teachers to drop in and ask questions?
Yeah, I've seen those. And unfortunately, some of the times are when I have a lot of Google Meets, as we all do, like a lot of Google Meets
Yes.
during the day. And it was like, I know some I really wanted to go to, and I'm like, nothing is fitting. I was always with kids.
Okay.
But I'll look again. I will look again.
Yeah. And also what you can do is, do you know which consultant is attached to your school? Are you distance learning or you are?
I'm at Breslau.
Okay, so you need to find out who's your consultant and then send them an email and they can set up a time with you.
Okay.
That's how we are reaching individual scenarios.
Okay. I'm sure I'm not the only one who's feeling this way.
I'm sure, yeah.
Fractions.
And fractions, as we recognize, is definitely a very hard topic to teach anyways. Yes.
Thank you.
No worries. Thank you. Thanks for asking this question.
Welcome back, everyone. I'm just going to make sure everyone is back by clearing all my breakout rooms. I think we're all back, actually. So. Perfect.
And then you need to present your screen again, Hebron?
Yes. So I didn't have to boot anyone. People all chose to come back, which is it's a good sign. All right, I'm gonna do this window. Excellent. Okay, so hopefully you had some time to discuss some of the concepts that are in these fractions. We're just gonna take a quick look at the the categories of comparing fractions, or the strategies of comparing fractions that you have. And this is from Van de Waal, in case you want to reference a text. So we have more of the same size parts. So when we looked at the 4/7 or 5/7, that sevenths tells us that it's the same size part, but we've got, instead of 4 or 5, so very similar to comparing whole numbers there, because the part sizes are the same. And then we have the same number of parts, but of different sizes. So we've got 4 pieces there and 4 pieces. The numerator tells us that. The fifths are a different size than the ninths. So which part is bigger is the question, right? And because ninths have more pieces to fit into the whole, each part or piece or partition has to be smaller, so we can say that 4/5 is greater. And then we have more and less than the benchmark of 1/2. More and less than 1/2 or a whole is a benchmark. So we look at 3/8, we see that 4/8 would be a half, so it's a little bit under a half. And we see that 4/7, 3.5 is a half, so it's a little bit over, so more or less than a benchmark, which can be a half or a whole. And then we have the distance from 1/2 or 1 whole. And that's what we were looking at when we saw that example prior in the slides where I showed the 6 and the 4ths. This is another example. We have 9/8. We've got 1 partition more than a whole. And we've got 4/3. We've got 1 partition more than a whole. So which one is further ahead? So an 1/8 is a smaller piece because you've got more pieces to fit, or partitions to fit into a whole. So it's not as far as a 1/3, which is 1/3 more than a whole. So these are the 4 categories of comparing fractions conceptually that you will be engaging with your students. So it's good to kind of break it down, anchor chart some of that stuff, and have them talk about it and engage with it. Okay, so that brings us to our questions. We're about 4 minutes over time. What I will do, because we are over time, is we would like you to give us a bit of feedback about this session. So if you can pop that into, I'll leave that Pear Deck up, and you guys can pop your responses, and then we'll start addressing any questions while that's available on your Pear Deck tab. And I think I'm going to stop presenting now, if that's okay.
And I will also stop recording at this point.
All right, we'll stick around. If you have, we have that Pear